Let's do some routing. Okay, so this video is going to be part 2 of routing between differing subnets over the same layer 2 segment. In the last video I did static routing, walked through that, got it working. Now I'm going to use EIGRP, and we're going to see if we can get that working too. Okay, so the topology is going to be the same. We have router 1, 2, 3, and 4 between router 1 and 2 using the E00 interfaces. We're going to be using 192.168.00/30.1 for router 1 and .2 for router 2. Between router 3 and 4 on the E00 interfaces, we're going to be using 172.16.00/30.1 for router 3 and .2 for router 4. And of course, between router 2 and router 3, we're going to be using the E01 interfaces, and so router 2 will be 2222/24, and then router 3 will be 3333/24. Okay, so to begin, I'm going to jump on the terminal and I'm going to implement EIGRP. So configure T, router EIGRP1, and next I put in the network statement. So I put in network 192.168.00, network 172.16.00, network 2.2.2.2, and this time I'm going to put a wildcard mask in to match all bits, and network 3.3.3.3, wildcard mask to match all bits. And so now we have EIGRP implemented on every router. So go type end. Let's take a look at this. Show IP route. So if you look here on router 1, you can see I've learned 2.2.2.0/24 coming from router 2, 192.168.02. Cool. I don't have anything else. I'll jump on router 4. Again, actually I don't have to type it, I already did it. You can see I have network 3.3.30/24 coming from router 3, 172.16.01. Right? Awesome. So if I go to router 2 or router 3, it's a different story here. Show IP route. You can see I have my directly connected interfaces. And the 2.2.2.2 on router 2 is being advertised back to router 1, but I'm not getting anything from router 3, right? Because I haven't formed an adjacency. And actually, if you take a look at this and you see that the errors that are coming across, EIGRP dual 6 neighbor info on Ethernet 01, it's saying it's blocked, not on a common subnet, 2.2.2.2/24. And it's coming from 3.3.3.3, right? So what can we do with this? Well, an interesting thought, how about trying to put an all-ones mask on the interface? Let's do a show run INTE01, take a look at it. So you can see I got that /24 or 255.255.255.0. So I'm going to change the IP address 2.2.2.2, 255.255.255.255, and it won't accept it. Bad mask /32 for 2.2.2.2. No problem, so it's not going to accept that configuration, but it will accept a different type of configuration. And in this case, I'm going to use a /31. Let's see what happens with that. So I'll do IP address 2.2.2.2, and network mask going to be 255.255.254. Okay, so now that I've updated that, let me go to router 3 and change it there as well. INTE01, IP address 3.3.3.3, 255.255.254. We're going to take a look here and see what sort of response we get. And you can see here that we did get the same error coming across. So neighbor 3.3.3.3 over Ethernet 01 is blocked. It's not on a common subnet, and it identifies that 2.2.2.2 is in a /31. So that didn't work either. So we need to try something else. We need to use a specific type of interface that will allow us to operate as a point-to-point link. Tunnel interface. So first thing I'm going to do, I'm going to go in here, I'm going to go to interface Ethernet 01. I'm going to change the IP address to something usable and not interfering with our tests here. So I'm going to use 5.5.5.1, 255.255.252 on router 2. Then I'm going to go to router 3, and I'm going to change it there as well. IT Ethernet 01, IP address 5.5.5.2, 255.255.252. In ping 5.5.5.1, and I got a response. So we have connectivity now. Now, on router 2, I'm going to implement an interface tunnel 1, set the tunnel source, Ethernet 01, tunnel dest 5.5.5.2. This is on router 2. IP address 2.2.2.2, 255.255.255. Now, since tunnels function as a point-to-point, unless you're doing point-to-multipoint, that's a whole different story. In this case, it's a end-to-end tunnel, point-to-point, so we don't need to specify a usable mask for broadcast. We can actually use an all-one subnet mask, and the traffic will still get between the two endpoints because of the fact that we've established a tunnel source and tunnel destination. Okay, so I put the IP address in on that tunnel interface. Let's take a look at it here. Do show run int tunnel 1. Everything looks to be on point here. Okay, so I have the tunnel interface configured. Everything looks good. Get out of here and do a show IP int brief. And there's tunnel 1 down there. It's up and up, so everything looks good, right? So now I'll go to router 3. I'm going to do the same thing. Different IP addresses. int tunnel 1. Tunnel source, Ethernet 01. Tunnel dest, 5.5.5.1. IP address is going to be 3.3.3.3, 255.255.255. Type an end. Oh, and you can see right there immediately we got a neighborship. So we'll do a show IP route. Take a look at this. So you can see here we've learned the 192.168.0.0/30 from 2.2.2.2. Router 2. Right? Interesting. So let's go to router 4 right now and do a ping and see if we can reach it. Ping 192.168.0.1. That would be router 1. And we got nothing. Okay, so let's do a PCAP and see exactly what's coming across the wire. So I'm going to go back to router 3, figure T, int tunnel 1. I'm going to shut it. Then I'm going to turn it back up. No shut. We'll see our neighborship. We'll come back up. We'll take a look at the PCAP, see exactly what did happen here. So we had our hellos. We finally had an update come across. So we actually want to look at the higher bit count, and you can tell that's the updates that are actually containing the networks. So let's say update coming from 2.2.2.2 to 3.3.3.3. And you can see here that it advertised that network 192.168.0.0/30. Then from 3.3.3.3 to 2.2.2.2, it advertised 172.16.0.0/30. And then if you look further down in here, this is interesting with EIGRP. From 2.2.2.2 to 3.3.3.3, it advertised 172.16.0.0/30. What? That's not right. So if you take a look at this information, you dig into it, you go to the wide metric, you can see that the delay has been set to infinity. So basically what it's done is it's poisoned the route in reverse. Since it learned the best route from that direction, it's trying to make sure that it will never advertise back out and let people know, hey, I have a way to get to this, when really it doesn't. All right, cool. So we got that. We got these individual networks that reside between router 1 and 2 and router 3 and 4, but we did not get advertised networks for the 2.2.2.2 and the 3.3.3.3, right? Okay, so we don't have that network. If I come back to router 2 and I do a show IP route, let's say for 172.16.0.0/30, the next hop is 3.3.3.3. However, I don't know how to get to 3.3.3.3. I don't have any information on that. And it's even more telling if I do a show IPsef to look at the hardware tables to see what's actually going on with forwarding. You can see that 3.3.3.3/32 is identified as no route. Okay. We'll see if we can fix that. I'll do the simplest thing. I'll put in an IP route on router 2 for 3.3.3.3, 255.255.255, and that's going to be tunnel 1. Then I'll do the same thing in reverse on router 3. IP route 2.2.2.2, 255.255.255, tunnel 1. All right. So now we should have reachability. If I look at show IPsef again, 3.3.3.3 is attached to tunnel 1. Awesome. And if I come back here and I try to do a ping from router 4 back to router 1, I get success. So, is there another way to do this? Yes, there is. So I'm going to do something else here. I'm going to get rid of these tunnels. No int tunnel 1. No int tunnel 1. Now I'm going to build loopback interfaces. And I'll set the IP address the same as I had it for the tunnel. IP address 255.255.255.255. Awesome. Go ahead and exit back to global config for that. INT-L0, IP address 3333.255.255.255.255. All right, cool. Okay, so I have PCAP running. Let me go ahead and configure the tunnels again. And this time I'm going to use an IP unnumbered, and I'm going to reference those loopback interfaces. IT tunnel 1, tunnel source, Ethernet 01, tunnel dest 5552, IP unnumbered L0. Shall run IT tunnel 1. You can see everything's configured and ready to go. I'm going to try router 3, IT tunnel 1, tunnel source, Ethernet 01, tunnel dest 5551, IP unnumbered, loopback 0. Okay, and you can see here we just formed an adjacency. So let's take a look at that and see what it looks like. So we can look at these EIGRP transactions, and you notice that once it goes to update, it switches from that multicast address to unicast direct between the two endpoints. Right? It's pretty interesting too. So if I look at these updates, I'll look at an update from 2222 to 3333, and I look at the networks that are being advertised now. Now I have that 2222/32. And if I look at the update coming from 3333, same situation. I have 3333/32. Awesome. So if I do a show IP route, let's say in router 2, if I look at the routing table in router 2, you can see that I have an EIGRP learned route for 3333 from tunnel 1. Awesome. If I go back to router 4 and I ping router 1 on 192.168.0.1, I get a response. So that's it. In the next video, I'll be doing this with OSPF, which is also different from EIGRP. It's pretty interesting. Thank you for watching.